Now let's look at the conformational inversion that takes place in a cyclohexane ring. And in particular, our cyclohexane will go from one chair conformation to an alternate chair, which is still a chair. We only say alternate so that we have some way to distinguish it from the first one. And this actually goes through another conformation called a boat, which is not nearly as stable as either chair. So the molecule, cyclohexane molecule, will spend most of its time in one or the other of the chairs, and sometime transitioning in between through a conformation called the boat. There's actually also a so-called twist boat on either side of the boat in between the chairs, but that's getting really complicated. So let's take a look at some models. And here we have a cyclohexane ring where we have, let's flip it around this way, marked one of the atoms in the ring right here with a yellow atom so that we can keep track of it. Notice that all of our purple elements are in the equatorial positions, and the green ones are in the axial positions, and that we just have what could be a simple cyclohexane ring if all of the substituents on the rings, purple and green, are hydrogens. Now let's first take a few minutes and see if you can draw this chair conformation. So if you've got something already, awesome, and if you want to skip along to whatever to check the answer, more than welcome to. We'll go through this exercise of drawing the chair again if you need to. So what we want to do is start with a pair of parallel lines that slope down as we go from left to right, and those are going to be for these two bonds in the ring that are parallel and pointed towards us. Oops, sorry, keep going out of the frame here. So then we draw an imaginary dotted line through the what'll be the middle of the ring that connects the top of the bottom line to the bottom of the top line, and then we extend that in both directions, and that's going to handle two more of the bonds in our ring, specifically this one and the one over here that is parallel to it. This one back here and the one up here that's parallel to it. And last, we connect with another set of lines to close that ring, and those represent two more bonds, the one back here and the one parallel to it that's up front here. Now note that this is the location of the atom that we have, that doesn't stand out very well, the atom that we've marked on the ring, the yellow one here, so that we keep track of it. And if we wanted to draw just little lines for the axial positions, we want to practice knowing where those are. Notice they're on every other carbon, and they alternate axial up, axial down, axial up, down, and wherever there's an axial, there's also one equatorial. And if it's axial up, it's equatorial down, and it's parallel to the lines that don't connect to that atom. So this element here has the purple and the orange line. The equatorial line is going to be parallel to the green ones. It'll come away from the center of the ring, and because axial is down, it'll be up. Here, we're parallel to the orange line, so axial up, equatorial down. Over here, parallel to the green line, and last, back here, parallel to the orange lines. One more up here, parallel to the purple lines, and so we've got our chair. Now what we want to do now is go through the conformational change called the cyclohexane ring inversion. And we want to call it an inversion rather than a flip, although it will effectively look like we've simply flipped the ring over like this. We're not doing that. We're doing a conformational change. So what we're going to do is take what's the footrest of the chair and make it the headrest. And this transition structure is the one that we call the boat. Notice now that the ends are pointed up like the bow and the stern of a canoe, and the two sides are like the edges of the boat. And then we take the other side that was up and we twist it down. Now notice that everything that was axial became equatorial, and everything that was equatorial became axial. And the other thing is that what's up stays up, what's down stays down. So the mantra we say is what's up stays up, what's down stays down, but axial and equatorial flip. So let me go through that inversion again. We'll take the low side over here, pull it up to be the high side. That makes our boat. Then we'll take the high side, twist it down to make it low, right? And then we're back to where we started. So again, back to the original, or back to the flipped conformation. Take the footrest, make it the headrest, take the headrest, make it the footrest. And let's draw this alternate chair structure, being cognizant of the fact that your yellow carbon is here, and where it was once lower than the nearby carbons on the page, it's now higher than the nearby carbons on the page. Now, if you want to pause the video now and try to draw this structure yourself, awesome. Otherwise, we'll go through it together now. And we start with a pair of parallel lines again, but this time they're going to slope up as we go from left to right. And those still account for those same two bonds. Next, we're going to draw our templating line. We're going to connect the bottom of the top one to the top of the bottom one and hope that should slope the opposite direction. And then we're going to extend that. Notice that we picked the other color. So we used green here, and so we're using orange here because the green bonds are now, or rather the orange bonds are now the ones that in our picture are going to look collinear. Then we'll close that ring out with another set of lines. And we have our marked carbon here. We'll circle that in gray so it stands out a little bit better. And notice that the substituent on that carbon that was in the equatorial position, which is equatorial up here, is now still up. What's up stays up and what's down stays down, but axial and equatorial switch. So you'll notice if we look around the ring, we have carbon, or one hydrogen on each carbon that's in the equatorial or axial position, but those are now the purple elements rather than the green ones. And the green ones are now in the equatorial position. And here we're parallel to the orange line. Up here we're parallel to the green line. Here we're parallel again to the orange lines. Parallel to the green line over here. Parallel to the purple line at the end here. So now we have the two alternate chair configurations. And you should practice drawing these because it's not easy. You can watch this video, of course, as many times as you want. And you want to be able to make this translation. Now, one thing we might note now, if we wanted to go from cyclohexane to, let's say, 1,4-dimethyl cyclohexane, then if we choose the, and let's make this cis 1,4-dimethyl cyclohexane, if we make our marked carbon the number 1 carbon, and let's just choose that to be up, then what we end up having is over here, we've got, because we're cis, This is 1, 2, 3, 4. We want that second methyl group to be up so that it's cis to the first one. Right? And we've got that configuration. Now, if we switch, notice that what's up stays up. So both of these still need to stay up. Let me box this one instead. They still need to stay on their respective carbon atoms. But when we do the ring inversion, they're going to go from, in this case, equatorial to axial. And in the case of the axial one, we're going equatorial. So practice this with other structures. We want to get fluid with this and be able to translate from one structure to the next.